in 1.1. And Chapter 1 is a review of some basic concepts. We're going to look at types of numbers. We're going to talk in this chapter about the basic operations, order of operations. Okay. We're going to talk a little bit about fractions. And we're going to begin in 1.1. And in 1.1, we're going to cover some basic concepts of the order of operations. And we're also going to talk about inequalities. Okay, so we're going to go ahead and talk a little bit about the order of operations. And we're going to expand upon this in the later chapters and sections as well. But we're going to start off with our basic order of operations. So we're going to look here at our basic order of operations. Now, in mathematics, we have to do things in a certain order. Mathematics is all about order. And so we don't want chaos, so we have to do things in a specific order. And so the first thing that we always do when we look at our order of operations is we look at our parentheses, square brackets, and then our absolute value bars. So those are going to be the first things that we work through. Now, once we have went through our parentheses, square brackets, and absolute values, and they're done in the same order. They're done first. We work from left to right. Once we have those completed, then we look at our exponents and square roots. So those are going to be done second. Then we go to multiplication and division, working from left to right. And then the very last thing that we work through is addition and subtraction. So that's our order of operations. I'm going to adjust the thermostat a bit so it's not so hot. Off a little bit here. So this is our basic order of operations. And when we work out problems, we're going to be working through order of operations. And we're going to first review a little bit about exponents. Exponents are your powers. So we're going to look now at our exponents here. And exponents are our powers. And let's just start off with one that we can work through. And we'll start off with 5 squared. Now, 5 squared, as you know, is 5 times 5, which is then 25. So what do? Well, we have what's called the base. So our 5 is the base. And the 2 is going to be our exponent. So that's our basic exponential here, or exponent. And we can also apply this to fractions. So let's say we have 3/5 quantity cubed. So this is just an example here. 3/5 quantity cubed. Well, what would that be if I write it out? All right, so that's going to be 3/5 times 3/5 times 3/5. And so fractions are going to work the exact same way whole numbers would. Now what we got to remember too is we do not need a common denominator. Why not? Well, the only time we need a common denominator is when we add or subtract. We're multiplying, okay? So we're not going to need any common denominators. All we do is multiply across. So we're going to multiply the numerators together, which is the top half, and 3 times 3 times 3, well, that makes that then 27. And down below in our denominators, we have 5 times 5 times 5, which is then 125. So our answer would be 27 over 125. Okay? So that's how you work with exponents. Now, I think someone may have walked in. So I got a new student back here. All right, I'll get you the handout here and the syllabus as well. You're sure welcome. We're going to make sure to keep track of the roll as well. Find our roster. Let's see. And who just walked in here? Is it Vanity or is it Karen? Karen. Okay. Oh, I'll mark you off, Karen. Thank you very much. Okay, so what we just did earlier was we just quickly went over the syllabus. We're just going over a little bit now out of 1.1. So you haven't missed much at all. You've got the homework packet that I passed out and the syllabus. So that's a little bit about exponents. Now let's go ahead and use the exponents with our order of operations. And we're going to start off with a simpler problem where we just go through order of operations and make sure we know how to simplify this down. So we're going to simplify the following. So if I gave you this and I said simplify, we need to make sure that we approach it in the correct order. Now, what's the first thing that we do? Well, order of operations says we do parentheses first. So inside the parentheses, I have addition. So we're going to go ahead now, and we're going to go through the parentheses. So we're going to go ahead and add those together. Okay, so adding those together, we get 3 then, times 4 plus 2 is 6, squared. Now, where do students make mistakes? Well, a student might make a mistake because they might multiply before they do the exponent. Exponent has to go first. So we don't multiply the 3 times the 6. We take 6 squared, and 6 squared is 6 times 6, which is a 36. Okay, so we did that next. And then what's our last step here? Well, our last step now is to simply multiply. And when we multiply, that gives us our final answer to be 108. Right? So our final answer on that one, when we simplify it, would be 108. We can't solve it because solving would mean we'd have variables. And we don't have variables. These are expressions. And all we're doing with these expressions is cleaning them up. So now I'm going to pick some from our textbook to look at. So I'll go ahead and pick some of these. Now some of these have fractions. Some of them may have square brackets and parentheses, both. So we're going to now go ahead and look at our textbook here. And I'm on page 34. And we'll just start off with question number. How about we look at 56? Okay, so question number 56. So we're going to use, again, our order of operations. And this one has square brackets and parentheses. The reason why we use square brackets is because we've already used parentheses. And you don't want double sets of parentheses. So this one we're going to go through, and we're going to make sure we work it out in the correct order. And you can skip steps when you work these out. I generally don't, because I want you to have a really good set of notes when you go back and review things. But when you're working these out on your own, you can skip some steps here. I'm not going to, because we're just learning the basics. So if I gave you this expression to work through and simplify down, first thing we need to do is we've got our square brackets, and inside we've got multiplication. Okay, they use the parentheses to denote multiplication. So the first thing that I would do is I would work on the inside and then work our way out. So we do the 7 times 3, and 7 times 3 is going to be your 21. And I picked this one just because of the square brackets. Square brackets are the same as parentheses. They can be used interchangeably. So just because you have square brackets, it is no different than parentheses. So now we're going to add, okay, and 1 and 21, that makes it 22. And again, these square brackets work like parentheses, and so that would be multiplication. And that should be 4 times 22, which should be that 88. And then the last thing that we do is we can go ahead now and we can add those together. And when we add those together, we should get 93. And that's going to be our final answer, which is then 93. So we watched order of operations and was very, very careful to make sure we followed that. Okay, you want to always make sure that you don't violate the order of operations. And we're just going to pick out some different ones that have different order of operations shown. 63 is a little bit different too. Again, 63 is going to be order of operations. So again, page 34, question 63, order of operations. This one looks very intimidating. It looks a lot more difficult than what it actually is. When you see this, you think there's going to be a lot involved, and there really isn't. The fractions just kind of complicate it a bit. And they make it look a lot more difficult than it really is. Because once you start working this out, it's not going to be a problem at all. But when students see something like this, you look at it and think, oh, this is going to be a lot of work, right? Okay? It looks like it's difficult. It's really not. Now, what we do in mathematics is we try to take complicated problems and we break them into smaller chunks so that we can break down the smaller chunks and put it all back together. So we do it in pieces. So when you see something that's complicated, well, we need to break it into small pieces. So we're going to break this down into the numerator, or the top half, and the denominator, or the bottom half. So your numerator is the top half. So for our numerator, we're just going to go ahead and write this out. And notice I split the paper so you can keep track of things. When I work things through, I always like to keep everything on the left nice and clean. So if it looks like I've got to use a lot of extra steps, I just draw a vertical line and I work over here. So on the right, this is going to be my work. What's mathematics all about? Being organized and being neat. Because if you start losing track of what is what, you'll make mistakes. And it's really, really frustrating because you transposed a number or you got mixed up as to where that number came from. So try to be as organized as possible. So here's our numerator, and we're going to do our parentheses first. So these go together, and those go together. So we've got 6 plus 2, that makes it an 8. And then we've got 8 minus 3, 8 minus 3, that makes that then a 5. So what are we going to do next? Well, our next step is multiply, and we're going to work from left to right. So 4 times 8, that's going to be your 32. And 8 times 5, well, that's going to be your 40. And we can add those together. And our top half, our numerator, is going to come out to be 72. So that's going to be our top half, our numerator. And we'll just put that over here. Always go back and double check and make sure you copied everything down, because that's another place where students make a mistake, and I do it too, is I accidentally copy a number down wrong. So make sure everything looks right, and it does so far. Now we're going to look at the denominator. And this is our bottom half of this fraction. So this is going to be our denominator, and we have 6 times 4 minus 2 minus 2 squared. Okay, so let's go ahead now and follow order of operations. 4 minus 2, well, 4 minus 2 is a 2. Parentheses go before exponents. Now, here's where students sometimes make a mistake with these. Notice this negative is out in front, and there's no parentheses around that at all. So what we do is we take the 2 and we square it. So 2 squared is going to then be what? 2 squared is 4. That negative is going to come down, and so that will be just like that. So it's not a positive 4 because you're not squaring a negative number. We're just bringing down that negative sign. And we'll talk more about negative numbers and powers here in a moment. But I just wanted to reemphasize that. A lot of times students will make a mistake because they see that and they think, oh, I'm squaring. When I square a negative, it becomes a positive. And it does, but that negative is out in front. So we square, and that negative drops down. And then we have 6 times 2, which 6 times 2 is your 12. And then now we have 12 minus 4. Okay, and 12 minus 4 is your 8. And that gets written up here. And what's our final answer then going to be? 72 divided by 8, which is a 9. But you see how we work through a really complicated problem in small pieces. And that's what we try to do. This may be a review for a lot of you as well, but we need to make sure we have a really, really good foundation. Because you might think you understand all the concepts, but you may really not. So it's good to have a nice review. So that's how I'd handle a problem like this one. I would break it up into pieces, simplify the pieces down. Now let's talk about inequalities a bit. So inequalities, we want to make sure that inequalities, they point towards a smaller number or open towards the larger number. So these are our inequalities. So we're going to talk quickly here about inequalities. So inequalities, we've got greater than, we've got less than, we've got greater than or equal to, and we've got less than or equal to. So these are our inequalities. Now when we talk about inequalities, we need to make sure that the inequality opens towards the larger number or points towards the smaller one. So it's either going to open towards the larger number, point towards the smaller number. So this is an example of one that would be true. 9 is greater than 6, right? Okay. It opens towards the 9, which is the bigger number, and it points towards 6, the smaller number. So this is true. Be careful with negative numbers. Is this one going to be true, or is this one going to be false? Negative 12. Is negative 12 bigger than negative 10? Is that going to be true, or is that going to be false? Well, which would you rather have? Would you rather have negative $12 in your account or negative $10 in your account? You'd rather have negative 10, right? It's a smaller negative number. This one's bigger, right? Because it's on the number line closer to 0. Because if we look at these, we look and see which one's closer to 0. Negative 10 is closer to 0. So is negative 12, is that bigger than negative 10? No. That would then be what? False, right? Because on a number line, we want the one that's closer to 0. And negative 10 is closer to 0, so it's the larger number. So when we look at negatives, we want the one that's closer to 0. That's going to be your bigger number. And in this case, negative 10 is closer to 0. So this would be a false statement. And let's do one more here. What about this one? 10 is less than or equal to 10. Do you think that's going to be true or false? Well, what do we know about inequalities? We've got greater than, we've got less than, we've got greater than or equal to, we've got less than or equal to. So in this case, okay, 10 is not smaller than 10, but 10 does equal 10. So it includes that equal, and since 10 equals 10, this one would be true. Now we're going to be looking at combining order of operations with these inequalities, and we're going to be seeing if these are true or if these are false. So let's see if these are true or if these are false. And we're going to work with question 82. So we're going to look now at question 82. And we're going to see if this is true or if this is false. So question 82, we've got this inequality, and we've got lots of order of operation components to it that we need to do first. So we're going to approach this problem just like we did a previous problem. And once we're comfortable with this problem, then we're going to go back and review a little bit about fractions. How to add them, how to multiply, and how to work with fractions. Because that's very, very important also. But I wanted to do it with whole numbers first, then do the fractions. So we're going to approach this one the same way that we approached a previous question. We're going to take this difficult problem and we're going to break it down into smaller, easier to work with components. And we're going to work with the numerator or the top half first. There's nothing to do over here on the left. This 7, it's done. Nothing I can do with it. So we're only going to be focusing on what's on the right. And we're going to look at the numerator. And so for the numerator, we have 3 times 8 minus 3 plus 2 times 4 minus 1. Order of operations. Let's make sure we copied it down correctly, because again, that's a common place where students make mistakes, is in copying it down. It looks like everything's right. So those can go together. Parentheses go first. 8 minus 3 is 5. And 4 minus 1. 4 minus 1 is your 3. Now we multiply. So 3 times 5 is 15. 2 times 3 is going to be 6. We add those together, and it looks like we come out with a 21. Is everyone okay with what I did there? I took the difficult problem and I broke it into smaller chunks, and I worked at each component individually. Denominator is going to be done the same way. So what do we have in the denominator? Well, in the denominator, we have 9 times 6 minus 2 minus 11 times 5 minus 2. Got to be careful with our signs here as well. Order of operations, parentheses are always done first. And what we have here is we've got 6 minus 2. 6 minus 2 is going to be a 4. And 5 minus 2 is a 3. Now we multiply. 9 times 4 is going to be your 36. The minus sign, that just comes down with it. So that's going to be coming right down here. And 11 times 3, that's a 33. And then 36 minus 3 makes it then a 3. And now we can finish out and answer the question if this is going to be true or false. Well, 21 divided by 3 is a 7. And is 7 less than or equal to 7? Yes, because it does equal. So in this case, you work it out, and you should get your answer to now be true. Okay. Now, what about fractions? How are fractions going to work? When we look at fractions, we need to remember a few things. So this is going to be for fractions here. For fractions, we need a common denominator when we add or subtract. So a common denominator is needed only for addition or subtraction. So we don't have to get a common denominator until we do our addition and subtraction. Once we've done our addition and subtraction, then if we have to multiply something later on, we don't have to get it again. All right, so we're now going to go ahead and talk a little bit about these fractions. And then once we talk about fractions, then we'll take a short break. So we're going to look at these fraction problems here. We'll do a couple of these, and I'll just pick them from our textbook. Let's look at question 43, and this is on page 34. We're going to look at question 43. And multiplication here, so 1/4 times 2/3 plus 2/5 times 11/3. Okay, now, what do we need to do first? These are multiplication dots. First thing we need to do is we need to do our multiplication. We have no parentheses, or we would do that first. So all we have here is multiplication, and we've got addition. So let's go ahead and multiply first. Now, when we multiply, do we have to have common denominators? No. Only time we have to have common denominators is when we what? When we add them together. Okay? Multiplication, we don't need that. So these can get multiplied together. So these are going to go together first. And we just multiply the numerators together. So 1 times 2, or 1 times 2 is a 2. And 4 times 3 is a 12. So we just multiplied it across the top and across the bottom. Now we do the next set the same way. And we can reduce these down sometimes as well. So if we need to, we'll reduce them down. And we've got 2 times 11. Well, 2 times 11 is 22. And then we have 5 times 3, which is then a 15. Now, we could have reduced here at the very beginning when I multiply. I could have reduced this 2 and that 4 down. And I could have rewrote that as a 1 and a 2. And that went down to 1/6. Same thing here. If you don't cancel out here, you can reduce this down. Because 2 twelfths, well, 2 twelfths, 2 and 12 have a 2 in common, right? And so 2 divided by 2 is a 1. And 12 divided by 2 is a 6. So you can either reduce it down at the beginning when you multiply, or you can multiply and reduce it at the end. So everyone see how I did that. So these both have a 2 in common, so I just divided both numbers by 2. Or you could have done it here. You could have seen these on your diagonal reduced by 2. Either way, you get the same result. So we went ahead and reduced. Now, we're going to be adding these together. So we need a common denominator to add these together. How do we determine the common denominator? Well, what we're going to look at, and this I think is the easiest way to do these, is we want to find the least common denominator here of 6 and 15. So here's how I do it. There's different ways of working through. You can use a factor tree. There's lots of, I think, ways that are more difficult than this. So what I do is I take my larger number. Okay, my larger number is 15. And then I see if it'll go into the smaller number. 15 divided by 6. That doesn't work, does it? Okay. So then we take our 15 and we double it. And if that didn't work, then we triple and we keep going. Now, 15 times 2 is 30. But does 30 go into our 6, our smaller number? Even. Yes. So my least common denominator is going to be a 30. Because 30 is divisible by 15. And 30 is divisible by 5, or by that 6 as well. So is everyone okay with how I did that? You take the larger number, and you just start multiplying by 2, 3, 4, 5, 6, until you come up with something that's divisible by the smaller number. Now, we came up with a 30. So that means we want the denominator, the bottom half of this fraction, on both of these to be 30. Now we got to go back and look and see what we need. And whatever we do to the top fraction, we have to do the bottom one as well. Well, 6 times what makes it a 30? 6 times 5, right? So we now need a 5 over 5. And 15 times what makes it a 30? Well, 15 times 2, right? Makes it 30. So we're going to need a 2 and a 2. Is everyone all right with this so far? Now we multiply again. So 5 times 1 is a 5. 5 times 6 is our 30. Next one, 22 times 2 is a 44. 15 times 2 is a 30. These are the same, so they can be now combined together. So those are going to be the same. If the denominators are the same, so if these numbers down below are the same, then we can just add the numerators together. So 5 plus your 44, 5 plus 44 makes it now 49, and the denominator is 30. So don't add them together and make 60. The denominators stay the same. Once these are the same, you just write down your denominator. You add or subtract your numerator. Okay. Let's work out one more of these. Then we'll take a short break. And we'll come back and work on the next section. So let's look at another one of these. That was question 43. So we'll do the next one. How about 44? Okay, 44 is going to be done in a very similar way. Well, I'll pick a different one because that one's got the same denominator. So I'll just make one up. So I'm just going to make one up. We're going to simplify this down. So we're going to try to simplify these fractions down. About 5/7 times 1/2 plus 6/5 times 3/8. So we're going to work with this one. I didn't want to give you the next question. I didn't want to give you 44 because it's got the same denominator. So I wanted to come up with something a little bit different. So I just changed them up here. Okay, now order of operations. What do we do first? The first thing we do is we need to do multiplication, and then we do our addition after that. So when we multiply, we do not need common denominators. And we can check on our diagonal. 5 and 2 have nothing in common. 7 and 1 have nothing in common. So we can now multiply. 5 times 1 is a 5. 7 times 2, well, that makes it now 14. The next one. When we look here, now we can either multiply across and reduce at the end, or we could cross cancel, which I think cross canceling is probably going to be easier. So we look at the 6 and the 8. Well, 6 and the 8 have a 2 in common. So since they both have a 2, we can reduce that down to a 3 and a 4. And now we can just simply multiply across. 3 times 3 makes it 9. 5 times 4 makes it now 20. Is everyone okay with that so far? Let's see how I did that. You could have just multiplied across. You got 18 over 40 and reduced it at the end. But I think it's going to be easier if we reduce it here first. Now what are we going to do? Well, now we need, since we're adding, we need our least common denominator. And we've got a 14 and a 20. What's the easiest way to find our denominator? Well, the absolute easiest way is start with the larger number. So we're going to start here with our 20. Does 20 divide evenly by 14? No. Okay, 20 times 2 would then be 40. Does 40 evenly divide by 14? Nope. Then 20 times 3. Well, 20 times 3 is what? 60. Does 60 divide by 14? Nope. Okay. 20 times 4 is what? 80. Does 80 evenly divide by 14? Nope. And you can get the numbers faster. I'm just showing you how I go through them. We've got 20 times 5. That's 100. Does that divide by 14? Nope. Okay. We're almost there. 20 times 6 is going to be what? 20. Divide that by 14. Nope. And again, you can go a little bit faster. I'm just showing you how I go through all the steps here. And we just did 6. How about 7? So 20 times 7, that's 140. That goes out evenly to be 10. So what would our least common denominator be? 140. You could have just looked at it and seen that a lot faster.
So you just start, like you said, at 1.
Yeah, what I do is I pick the larger number. And I say, okay, so we started with 20. Does 20 divide by 14? Nope. 20 times 2 is 40. Does that go? Nope. 20 times 3 is going to be the 60. Doesn't work. 20 times 4 is 80. Still doesn't work. 20 times 5 is 100. Doesn't work. But then 20 times 6 is 120. Doesn't work. But 20 times 7 is what? 140. And 140 does divide by 14. Once you do a lot of these, you can look at it and see. And you can just kind of look at this and say, okay, I'm going to try 14 times 10, see if that works, get it that way. But when we're just learning, what I tell you to do, the easiest way, I think, is to just take the larger number, start multiplying and dividing by the smaller one. So try 20 times 2, 3. And again, once you do a lot of these, you can just kind of look at it and say, okay, 140 is going to work. But until you get to that point, just work it out this way. Now we're going to use our common denominators here. And we look at each one, and we'll take a break after this question. Okay, we look at each one. So 14. 14 times what is going to make it 140? Someone tell me? 14 times 10, right? Okay, so we're going to use a 10 over 10 here. 20 times what makes it 140? 20 times, in this case, 7, right? So 20 times 7 is 140. So we're going to use a 7 over 7. Now we can go ahead and multiply. So 10 times 5. 10 times 5 is 50. That's going to be over 140. 9 times 7, that's going to be your 63. 20 times 7 is 140. Now, can we combine them together? Yes. We're adding. These can go together. Why? Because they have the same denominator, right? They're both 140s. So what's our common denominator? Common denominator is 140. What about the numerator? Well, we just add across. And when we add across, it looks like 50 and 63. Well, that should make it then 113, doesn't it? Okay. And I don't think that's going to reduce down any, because that should be as small as it'll go. Later on, we'll reduce down some more fractions, but this is just kind of the basics here. So we're now going to go ahead and take a short break, and we'll meet back here at, let's say, how about 9:40? So try to meet back here in about 10 minutes at 9:40.